Okay, we're going to take a look at fractions, decimals, and percents and how they are all related using number lines. So this is going back to the beginning of school when we defined a fraction using a number line. So let's take a look at doing that again. All right, so you should already have the definition of a fraction, the collection of all nths or partitions in m over n, as m runs through all non-zero whole numbers. So again, if you have a number line, you have to have a starting point, which we will call 0. And we have to identify a line segment, so let's say here. So you have to identify or define what is 1. In this case, this line segment right here is going to be 1. And now we can partition it, let's say, into 4 equal parts. So here's 4 equal parts. So this first segment would be 1/4. The second segment would be 2/4. Third segment would be 3/4. Fourth segment would be 4/4. And if we were to keep going, then the next segment would be the 5th copy and 6th copy and so on and so forth. So that should look familiar to you. All right, so how does that pertain to a definition of a decimal? Well, a decimal is a fraction, but now we're using a specific denominator, has to be a power of 10. So in this case, we have 1,489 hundredths. So if you get into exponents, another way you can write this is 1,489, and this is a power of 10. 10 times 10 is 10 to the second power. Well, this 2, this exponent, becomes important because that's going to tell you where to put your decimal point. Decimal is a power of 10. So that means that we can rewrite this as 14 decimal 89 hundredths, and that's for 8 tenths, 9 hundredths, 89 hundredths. Well, 1,489 is obviously an improper fraction over 100. So you can get 14 hundredths, 14 groups of hundreds, but you're going to have 89 left over, so 89 hundredths. So in actuality, someone decided we don't want to write fractions anymore. We want to write them as decimals. So this is how they came about, just getting rid of the fraction sign and replacing this with a decimal. So we can write this as 14 and 89 hundredths. And that's it. Let's practice it with this one. We have 24 hundred thousandths. So same thing. We have 24 as a whole number, 24 copies of 100,000. Well, 100,000 is 10. If that's 10 times 10 times 10 times 10 times 10 is 100,000, that's 5 times. We've done that 5 times. So how many times are we going to move the decimal point then? Put in our decimal point. We have to have 5 places. So it would be point, let me make this a little bigger, 0.00024. So tens, hundreds, thousandths, 10 thousandths, 100 thousandths. We have 24 hundred thousandths. So here's the decimal way of writing this fraction. All right, let's take a look at the last one, 58,900. 58,000 copies of 10,000. 10,000 as a power of 10 is 10 times 10 times 10 times 10, so that's to the 4th power. So in our whole number, 58,900, I move my decimal point over 4 places. So now I have 5 and 89 10,000ths. Okay, because again, this is 800 or 8,900, but it's 89 10,000ths. Now, you're probably wondering, wait a minute, we have these extra zeros here. I don't have to have zeros. Well, now you're talking equivalent fractions because you're right. This would be 10 over 10, which is 1. You can cancel that out. 10 over 10, which is another 1. And now you're left with 589 hundredths. 589 hundredths. And if 100 is 10 to the second power, then 589 decimal point at the second spot is So these two numbers are equivalent also, right, by the fact that you can use equivalent fractions and cancel out this power of 10. All right, so how does that affect percent? Well, a percent is a complex fraction, and the denominator of that complex fraction is 100. So here is 2%. Well, 2% is 2 copies of 100. All right? Well, 2 copies of 100 is the same as saying 2 times 1 over 100. And that 100 here is again 10 to the second power. So do you see where we're going with this? All right, well 2 with 2 decimal places is 0.02, 2 hundredths. Now you can also turn that into a fraction, because 2 out of 100, we can find an equivalent fraction by dividing this by 2, and you also get 1/50th. So 2% is the same as 1/50th, but it's also, as a decimal, it is 0.02 or 2 hundredths. Here's your tenth spot, here's your hundredth spot. Okay, what about 7.5%? That would be 7 1/2 over 100. And that means 7 1/2 copies of 1/100th, or a partition of 100. So 7 1/2 times 1 over 100. Well, again, we can turn this back into a mixed number, so it'd be 15 copies of 1/2 times 1 over 100th. And you get 15 200ths. But again, keeping in mind that this is 15 200ths. If we go back to 100, it's just half of that. So half of 15 is 7.5 over 100. And this is at power 10 again to the second power. So now we've got to take our decimal point and move it 2 places over. So it is now 75 thousandths. Okay, so 75 thousandths, moved it 2 places, is the same as 7.5%. All right, so let's take a look at 40%. 40%, if you wanted to count this on a number line, this is a number line with the line segment 0 to 1 partitioned into 100 equal parts. If 40% means 40 out of 100, then on our number line it would be 40 copies of 100, or 1/100th, I should say. All right, so from there, let's say we can make some equal groupings here, and you can kind of already see them, but hundredths are a power, or can be grouped into groups of 10. So if we get rid of those, now our partitions are not hundredths, but they are tenths. So here's 1/10, 2/10, 3/10, and so on. 4/10 is right here. So by virtue, or by definition of equivalent fractions, 40 100ths is the same as 4/10. And we can represent 4/10 as a decimal as just 0.4. All right, let's take that one step further, and actually let's just kind of summarize. So 40 out of 100 is the same as 4 out of 10, which means that we can write that as 0.4, or 0.4 if you want to do that. All right, so how is that as a fraction? Well, we can go ahead and do some more combining, because these 10 partitions can also be grouped into 5 equal partitions. All right, so that is where here now we have 1/5. This is a group of 1/5. So the next one would be 2/5. And so by reducing this, 4/10 can also be called 2/5. So now we've gone from 40%, which is 40 out of 100, to 4/10 because of equivalent fractions, and also by equivalent fractions, 2/5. So 40% is the same as 4/10 is the same as 2/5. All right, let's take a look at 2/3 and do the same thing. So for 2/3, that would be, we want to, if we're going to turn this into a decimal, we want to get something that is a power of 10. So what can we multiply 3 by to get to 10? Well, if you know anything about your math facts, you know that 3 can't be multiplied by anything to get exactly to 10. We can start with 3, and we end up with 6/9. Okay, not close enough. It's not 10. Well, let's make it smaller. Let's go ahead and multiply it by 3.3. Well, now you have 66, or 6.6, and 9.9. Close to 10, but still not 10. If we kept going, we could also say this would be 100. Well, it would be 66 and 99. Okay. But we're still not at tenths. We can go to 1,000 and get closer still. We'd end up with 999 and 666. But I think you can see where we're getting at is that you're never going to get to 1,000. So that is why when you take a look at 2/3 as a decimal, it is a repeating number. We can only get as close as 6, and then it keeps repeating. We can keep adding 6's, but that's where you usually see 2/3 is the same as 0.6 repeating. Or sometimes people will round it and call it 0.67, or they just stop at 0.6 and call it repeating. So how does that work as a percent? Well, if you have 0.66, it can also be out of 100. It's going to be 66 out of 100. But keep in mind that keeps going. So it's 0.66 repeating. All right, which that's where you get 66% if you're rounding. Or some people say 66.6 repeating percent. Or some people round it up if they need a whole number and call it 67%. So again, 2/3, even though it's not an easy fraction because it doesn't go into 10, 1,000, 100,000, can still be written as a decimal, albeit repeating, and it can be written as a percent. So 2/3 is the same as 0.6 repeating, or 6/10 repeating, and then it's also 66%. All right, so that's a little bit about how decimals, fractions, and percents are related, and we will continue this not with number lines, but with fraction pieces tomorrow in class.